Force and motion are related to potential and kinetic energy. I can compare and contrast potential and kinetic energy. Starter. Compare and contrast potential, stored energy due to position, and kinetic energy, energy of motion. Describe the relationship between potential and kinetic energy in this picture. So as the cart goes down the ramp, you can see your potential energy decreases. Here it's very high. As your potential energy decreases, your kinetic energy increases. So when the cart gets to the bottom, you can see your kinetic energy is low. Here is a better visual. You can see your potential energy decreases as your kinetic energy increases. So let's follow the path of this race car. So at the top of the ramp, high potential. As it goes down, it's converted into kinetic. Potential and kinetic energy have an inverse relationship. When potential energy increases, kinetic energy decreases. When potential energy decreases, kinetic energy increases. We're going to click on the potential and kinetic energy of a roller coaster for a visual representation of the inverse relationship between potential and kinetic energy. The greatest gravitational potential energy and the least kinetic energy is at the highest point of the system. So here again, you have the greatest potential and the least kinetic. Down at the bottom of the roller coaster, that's where your kinetic energy is the greatest. Kinetic energy is energy of motion. It's where it's going the fastest. So you have the least gravitational potential energy and the greatest kinetic energy at the lowest point in the system. So high potential energy, low kinetic energy. Low potential energy, high kinetic energy. What is an example of energy transforming? So here at position A, all potential energy because it's waiting at the top of the hill. At point B, you still have some potential, but potential is turning into kinetic. At point C, all energy has been released, so this is all kinetic energy and no potential energy. And then as you go back up, you gain potential energy back because we're back in a position in which we could fall. So, definition of gravitational potential energy. It's energy an object possesses due to its position and height above the earth. The higher off the ground, the more potential energy. The closer to the ground, the less potential energy. Kinetic energy, energy of motion, energy being transformed. Let's drag and drop the boxes on the right to the correct places in the image. So where would we have the greatest kinetic energy? Your greatest kinetic energy is at the lowest position. So I would say that would be position X, where you have the greatest kinetic energy. So remember, if you have the greatest kinetic energy here, you have no potential. So we can say least potential energy, both at that same position. Okay, and then when you are the highest above the ground, that's where you have the greatest gravitational potential energy. So let's drag and drop greatest potential energy. So inversely, we would have the least kinetic energy. Okay, and then if we look here halfway up the track, what we have here is kinetic energy is then decreasing while potential energy is increasing. And then down here, we have our potential energy is decreasing while our kinetic energy is increasing. Let's drag and drop the boxes to the correct place in the image. This was a former STAR test connection question. So when I look at an image, I like to point out where do I have the greatest potential energy and the least kinetic. So that's going to be your highest point. I always just like to start with that. So we have the greatest potential, so that means least kinetic. He's at the tippy top of the hill. The greatest gravitational potential energy, because gravity can pull him down. Now here, he's halfway up the hill and halfway down the hill. So if he's going uphill, he's going to lose his kinetic and gain potential. Okay, and then down here as he goes down, that potential energy is decreasing while his kinetic energy is increasing. All right, let's have a class discussion using this sentence stem. So I'm going to talk about different locations, and we will compare and contrast potential and kinetic energy. So we can say at location A, potential energy is great and the kinetic energy is the least because we are at the highest position of the track. At location B, the potential, we're losing potential energy and increasing kinetic energy because we're going downhill. At location C, the potential energy is the least and the kinetic energy is the greatest because we are at the lowest point of the track. At location D, the potential energy is increasing and the kinetic energy is decreasing because we are gaining height above the ground. Okay, let's watch the video clip before completing the next slide. So we're looking at potential and kinetic energy in a pendulum. So let's click and drag and drop the boxes to the correct place in the image. location A has been done for you. So I will do location A. So here at the pendulum, we have the greatest potential energy. Okay, and then I like to look at the lowest point where I know that I have the greatest kinetic energy. So with that being said, now I can talk about if I have the greatest potential energy here, I'm going to have the least kinetic energy. And if I have the greatest kinetic energy at the lowest point, I'm going to have the least potential energy. Okay, and then I want to talk about these positions in between D and B. So potential energy decreases while kinetic energy increases. So here you have the greatest potential, and then your potential energy decreases as you gain kinetic energy. Then over here, if we look at this point of the pendulum, we can say kinetic energy is decreasing while potential energy is increasing. Let's look at another STAR test question. It reads, a demonstration helps students understand the principle of a roller coaster design. Which answer choice correctly describes the ball's kinetic and potential energy? So we have W, X, Y, and Z. Which answer correctly describes the kinetic and potential energy? Let's look at our first answer choice. The ball has more potential energy at position X than it does at position Z. That's incorrect because Z is higher, so we'd have greater potential energy here than we do at X. So we could cross out answer choice F. Answer choice G. The ball has more kinetic energy at position Y than it does at W. So do I have more kinetic energy here than I do at position W? Yes, I do. Because at position Y, you understand it's the lowest point closest to the ground. So that's where you are going to have the greatest kinetic energy and the least potential. So that would be the correct answer choice. But let's continue to just look at our other choices. The potential and kinetic energy of the ball are equal at position X. No, potential and kinetic energy are not equal here. And then lastly, the potential energy and kinetic energy of the ball are the greatest at position Z. No, kinetic energy is at the least here, but your potential energy has increased. All right, a few more STAR test questions. At which position does the ball have the greatest kinetic energy and the least potential? Remember, to have the greatest kinetic energy, that's energy of motion. So you want to find where the object is closest to the ground. So if you look at position 2, the ball is closest to the ground, so that's where it has the greatest kinetic energy, energy of motion, and the least potential energy. Now, if this question said, at what position would you have the greatest potential and least kinetic, that would be at position 1, just before you drop the ball, because potential energy is energy of elevation. The higher off the ground, the greater gravitational potential energy it has. All right, and STAR test question. A student drew a diagram below to show the movement of water through a hydroelectric dam. So here's a hydroelectric dam, and they're pointing at these positions, W, X, Y, Z, very similar to the other STAR test question. It's asking at what location is the potential energy of the water the greatest? So where would the potential energy of the water be the greatest? The energy would be the greatest at the highest position. So where do you have the greatest gravitational potential energy where the water is the highest. So that would be W. You would have the least potential energy here at Z, but the greatest kinetic energy, energy of motion. Okay? So remember, if you have the greatest potential, you have the least kinetic. If you have the greatest kinetic, you have the least potential.